In this lecture, let's discuss two more continuous scales. So in the previous lectures, we have been discussing using linear scale, which is a continuous scale. Continuous scale means it provides continuous output for the provided continuous input. So linear scale is a continuous scale, and in this lecture, let's see two more continuous scales. They are power scale and log scale. So you might be knowing power and log in terms of mathematics. That is 5 to the power of 2 is 25 or 2 to the power of 3 is 8. So that is the power. That is, we are multiplying a number by the specified exponent. That is 2 to the power of 3 means we multiply 2 into 2 into 2. That is 3 times, which gives 8. Similarly, 5 to the power of 2 means we multiply 5 into 5. That is 2 times, which is 25. And you might be knowing the log as well. The log of 25 base 2 is 5. That is 5 to the power of 2 is 25. And the log of 25 to the base 2 is 5. So we can have power scales and log scales in D3. The power scale interpolates using power function and the log scale interpolates using log function. So in this lecture, let's see how to use the power scale and log scale. So for the power scale, let me use numbers like 2, 3, 4, 5, 6, 7, 8, 9 and 10. So here we are not going to use the linear scale. So let me delete this, and here let me define a new variable power scale equals D3 dot, the name is scale POW. That is the name we need to use for power scale. Then we need to specify the exponent. So if I want to find 5 to the power of 2, the 2 is the exponent. If we want to calculate 2 to the power of 3, then 3 is the exponent. So let me specify exponent as 3 here. And again we need to specify the domain, that is the input domain and range. So let me specify dot domain. Just to avoid complexity, I'm just hard coding the values here. So let me specify 0 as the min and 15 as the max. Here the minimum is 2 and maximum is 10. Still I'm specifying minimum as 0 and maximum as 15. You can use the min and max methods if you want. We have already seen how to use min and max methods. Here I don't want to include that as well, because here we want to concentrate on power scale and log scale. Okay, so I have specified domain. Next I need to specify range. So let me specify dot range. What are the values? I can specify 0, height. Here height is 500. Okay, so I have defined power scale. Now instead of my scale, I can specify power scale, which will return the corresponding values. So let me copy this, paste it here and as well as here. Now let me save this and show you the output. See, we are seeing the vertical bars in the shape of a curve, right? Let us try to change the value of exponent from 3 to 5 and see the change. Let me save this. See, now the values for 2, 3 and 4 are not even visible. So instead of 5, if I try 0.5, so it will be actually the square root, right? So let me save this and show you the output. See, now the values are displayed like this. So when we specify a value less than 1, it will not be actually power, it will be log, right? So here, instead of specifying an integer value, we have specified 0.5, which is actually the square root. So let me change it back to 2. So here you can specify the exponent using exponent, and within brackets you just have to specify the value. Let me show you the output again. This is values for 2. So this is the power scale where we can specify the exponent, and the name of the method is scale POW, and the power scale interpolates using the power function. Next, let us see the log scale as well. In case of log scale, it interpolates using log function. So let me have another array where numbers 1. I'm naming it like numbers 1, and let me specify the values like 100, 1000, then 10,000, then lakh, 1 lakh. So 1, 2, 3, 4, 5, and also 10 lakhs. So 10, 100, 1000, 10,000, 1 lakh, 10 lakhs. So these are the values I'm going to use. And here I have to specify, instead of exponent, it will be base. Suppose I want to find log with respect to 2, I can specify the base as 2. So here let me specify where log scale, okay, equals d3 dot scale log, that is the name of the method, and instead of exponent I need to specify base. Let me specify it with 2. Again I need to specify the domain and range, that is the input domain and output range. So let me specify dot domain within brackets, within square brackets, let the minimum be 10 and let the maximum be this value. So let me paste it here, and for the range it is the same. So let me copy this from here and paste it. Okay, let me align it properly, and instead of power scale let me try to use log scale. So log, and here as well instead of power scale it is log scale. Now let me save this and show you. Okay, we are not getting any output. Okay, here we have used numbers. Instead of that it should be numbers 1, right? We need to join it with the numbers 1 array. So let me save this. See, these are the values for the log. We have specified the maximum as 10 lakhs. That is why it is displayed like this. Suppose I add one more 0 here, that is for the maximum, and save and see the output. See, these are the values. So here it is using a log scale, and log scale interpolates using a log function. As we have specified the base as 2, these numbers log values are calculated with base 2. Suppose instead of 2, if I specify 5 and save, see, still the values are same because it is mapped with respect to this available output area. So in this lecture we have seen 2 more continuous scales in addition to linear scale, and they are power scale and log scale. To use power scale, the name of the method is scale POW, and we need to specify the exponent in case of power scale, and in case of log scale it is scale log, and we have to specify the base, that is with respect to what we need to find the log. So you can use power scale and log scale if you want in case of D3 scales.